Alright, so today we're going to be doing some trig proofs, and the first problem we have here is tangent of x plus cosine of x over 1 plus sine of x is equal to 1 over cosine of x. Alright, well, you can look at this in a way where you can change tangent of x into sine of x over cosine x. So let's just do that and see what we can end up with. So we got sine x over cosine x plus cosine x over 1 plus sine x. Okay, I'm just going to leave it like that. I'm not going to write this side over here. So we can actually combine these two fractions by multiplying this denominator over here and this denominator over here. So I guess we can just do that. So we have 1 plus sine x, so 1 plus sine x times sine x. Okay, plus cosine x times cosine x is just cosine squared x. This is all over, and then cosine x times 1 plus sine of x. So that makes this pretty straightforward. Okay, so if you don't know what I just did, I just multiplied this by this denominator. So 1 plus sine x over 1 plus sine x, which is just 1. And I can distribute the values there. And that just makes it easier to be able to combine the fractions. So now what I can do, I'm not going to distribute this, but I'm going to distribute this. This turns into sine x plus sine squared x. And if you notice, we're going to get the sine squared x. Sine squared x plus cosine squared x is just 1. So this, all this is sine x plus 1 over cosine x times 1 plus sine x. Right? So I just distribute this, and then I notice that sine squared x plus cosine squared x is 1. So that's where that comes from. And if you notice, these two things are the same, so I can actually just cancel them out, and I'm left with 1 over cosine of x. Alright, so our second problem here is pretty big, but we can fairly easily solve this if we just distribute this out, because this is just two things being multiplied together, so we can just distribute it, and then we'll see how things cancel out there. So this is just sine x cos x minus sine x cotangent x. This is minus sine x cotangent x, and then we can this is minus tan x cos x, so minus tan x cosine of x, and then this negative and that negative will cancel out to be a positive, so it's just plus tan x cotangent x. Alright, so tan cotan. Alright, so there's a lot here, but we can easily start canceling things out. Cotangent x is cosine over sine, and so we have a sine here, so if we cancel out the two sines, this just becomes cosine. This is cosine of x. Okay, same thing here. This is, so this is, tangent x is sine over cosine, and the cosines will cancel out, and this just becomes sine x. And then the tangent and the cotangent, well, cotangent is 1 over tangent, so this just becomes 1. So things cancel out really nicely here, and we can just rewrite this as sine x cos x minus cos x minus sine x plus 1. Okay. And all we have to do is factor to get to this. But how do we factor? Well, you can look at it in this way. Let's try to factor out a cosine. Or let's factor out a sine, because that's what's first here. So if we factor out the sine, there are only two terms where we can factor out the sine, and that's here and here. Everything else doesn't have a sign, so why would we factor it out? So let's do sine x times, we have cos x minus 1, okay? And you can see here, cos x minus 1 is right here. So we already have that part done. We just have to figure out the rest, okay? So all we have is this minus cos x and this plus 1. Well, if we factor out a negative, we can turn this into that. So here, I'll show you what we're going to do. So we're going to do minus 1 times cos x, and it's no longer going to be a plus 1 here, it's going to be a minus 1. So we have sine x times cos x minus 1 minus 1 times cos x times minus 1, okay? And so this allows us to just factor it out like this. Sine x minus 1 times cos x minus 1. And that works because all we're doing here is we're factoring out cosine x minus 1. So if we factor this out, we're left with sine x minus 1. And so that's what we're doing here. And that is exactly the same as that. So we proved that. A little more intensive there. It was pretty easy with the steps, but it's just a lot of thinking going involved. So yeah. Alright, so for number 3, we are taking this expression, adding it to this expression, and we should get a squared plus b squared. And we're using phi instead of x now. So what can we do? Well, we can actually just distribute everything, and it's a lot, but it will eventually cancel out. And there aren't really many steps with this, so it'll be pretty quick. So let's just write it all out, just so we can familiarize ourselves. So a sine phi plus b cos phi. If we're squaring that, this is just going to be a sine phi, and the whole expression is squared, so I'm just going to do a squared and then sine squared phi, okay? Plus, that's going to be 2 times our first term times our second term, so that's just going to be plus 2 a sine phi b cos phi, okay? Plus b squared cos squared phi. Okay, that's a lot. I don't know if we'll have room for this part, but yeah, it is a lot. But you'll see how it factors out nicely later on. So then we're taking this. This is a negative version, so the only thing that's going to change is that this is going to be a negative sign. So we're just going to add that to, well, obviously, also the expression's slightly different. It looks the same, but it's different. So then we have a squared cos squared phi minus 2 a cos phi b sine phi. See, this is a lot, and sometimes it can get a little confusing, but yeah. We don't have space, but I'm just going to write it down here. Plus b squared cos squared phi. Okay. It's very long. It's a very long expression, but as you can see immediately, these two are the same. We have our we have our 2a here, we have a b, and then we have a cos phi and a sine phi. So, and then this is a plus and this is a minus, so these two just cancel out nicely. Okay. And then we have this a squared and that a squared, and this b squared and that b squared. So if we just group them together, we can really just factor out some stuff. So let's take a squared, and then we have this sine squared phi and this cosine squared phi. So we have, let me do the sine first. So sine squared phi plus cosine squared phi. Okay. And then we have this b squared, these two here with this, hold on. No. This is a sine. I messed up twice here, but yeah, this is a sine, okay? Alright, so then we're adding this to a b squared, and then we have this sine squared phi and this cosine squared phi. So we have sine squared phi plus cosine squared phi. And what do you notice? Well, this is just 1, and this is 1 too. Sine squared plus cosine squared is 1, and so this just turns out to be 1, that turns out to be 1, and we're left with a squared plus b squared, and that's exactly what we should end up with. So yeah, it was a long expansion, but it ended up being really simple. So yeah, those are the trig proofs. I'm probably going to do a lot more trig proof videos in the future, because there are a lot of different kinds, and they're very interesting sometimes. Things where you don't even have any numbers, you just have variables. And yeah, so thanks for watching, and I'll see y'all later. Bye guys.